Coming up on This Week in Computer Hardware, NVIDIA makes the GeForce RTX 2070, 2080, and 2080 Ti official at Gamescom 2018. Should you pre-order the Founders Edition or hold off on these ray tracing wonders? Where to get the best deals on PC components and the latest in LED rainbow unicorn vomit for your PC. All that and more coming up next on TWiCH.
Netcasts you love.
From people you trust.
This is TWiCH.
This is TWiCH, This Week in Computer Hardware, episode 480, recorded on August 23rd, 2018. NVIDIA GeForce RTX 2070, 2080, and 2080 Ti are official. Welcome to TWiCH, This Week in Computer Hardware, TWiCH's weekly show that aims to bring you the most useful, most engaging, most delightful, most affordable, most compelling, and perhaps even most evil hardware news available in this universe or any other known or unknown universe. I saw that in the contract once at Discovery, and I just like the whole idea of covering all the unknown universes. The universe we are actually knowing and covering today is going to be the world of hardware, specifically PC hardware, perhaps a dash of mobile, maybe a little console action, but mostly because of the launch of the long-awaited, or the announcement, more accurately, of the long-awaited 2080 from our friends at NVIDIA. The 2080, 2080 Ti, and 2070 have been announced. Or I should say the GeForce RTX 2070, RTX 2080, and RTX 2080 Ti Gamescom in beautiful Cologne, Germany. My partner in crime at TechThing, Shannon Morris, has been over there helping NVIDIA, doing hosting and interviews and stuff. Ryan Schrautz of PC Per is over there, along with a whole lot of other people who write about graphics for a living, discussing the wondrous world of ray tracing, and apparently not getting a lot of hands-on times with games that do not include what I will affectionately call the RTX in the new GPUs. Joining us today, Alan Malventano of PC Per. Have you heard from Ryan about the hands-on experience with the new NVIDIA GPUs yet, Mr. Malventano?
I have not. I've not heard anything from Ryan. Ryan is currently on airplanes. Oh. So I will probably be hearing from Ryan later this evening. But yeah, so how about them prices on those RTX cards?
So these are Founders Editions, which means in several weeks we should have a not Founders Edition that will knock, I'm going to say, $100 off the price. I could be wrong about that. But currently you're looking at the GeForce RTX 2080 Ti at $1,200, GeForce RTX 2080 at $800, and the GeForce RTX 2070 at a mild $600, which actually does seem kind of steep, A, because GPU prices are no longer all of the money we can take from you, all of the Bitcoin years. But it was interesting looking at Camel earlier at like 1070 GPU prices. I'll pull them up again. But like a GTX 1070 right now, currently $400 on Amazon. Maybe $460 if you want to get fancy. GTX 1080s. This is the lowest that we've seen these prices in a long time, and it's kind of there was no massive drop in price when this announcement was made. Well, there's a little bit of a drop in price, but it's funny. Like, I'm looking at this in beginning of August. We probably saw the lowest prices we've seen in forever. Since May of 2017 on some of these GPUs. And it looks like others, depending on, because there's so many different models. You're talking about a GTX 1080 for $470 right now. Here's a Zotac for, $449. Here's a EVGA GTX with 11 gigabytes of RAM selling for $669. But generally speaking, that's a 1080 Ti, pardon me. But generally speaking, you're looking at, let's call it $500 as a nice round average, or a very rough average on GTX 1080s. And GTX 1070s are literally back to the price I paid for mine a year and a few months ago to do a review of an 8K monitor.
Before they all spiked up. So what I've noticed on this pricing is, first, there's that disparity, right? There's
right.
You had NVIDIA CEO on a stage announcing one set of prices, while at the same time on the NVIDIA site there were pre-orders for a different set of prices that were higher than what was being announced. So maybe the announced prices are, okay, here's where the eventual MSRP is going to be, but if you want to pre-order these things, you're going to pay a $200 premium for a 2080 Ti. You're going to pay a $100 premium for a 2080. And that's kind of steep already. If you look at not those kind of excessive prices, but at the MSRPs, those MSRPs roughly match the previous generation, but one rung higher prices. In other words, you compare a RTX 2080 to a GTX 1080 Ti, roughly, as far as price goes. And what they appear to be doing is scaling that price proportional to the raster performance. In other words, the performance that you and I are used to hearing about, right? So, because there's another article we'll get to in a minute here that shows that like a 2080 is roughly 1.5x a 1080 in raster performance. Putting aside the new features, just like, okay, now you have some more of the older style cores for raster, for your kind of regular non-fancy graphics. And so the pricing sort of makes sense in that respect. The pricing is an advantage for the new generation if you also consider those RTX specific features. RT standing for ray tracing. Basically, there's extra silicon in these new parts that's able to do not full ray tracing, but when combined with raster, with a raster pipeline, you're able to get sort of a hybrid result, and you're able to get things like actual reflections off of surfaces, lighting coming from more than just one or two point sources in the scene. Basically, a bunch of things that just the end result is a much more realistic looking scene in whatever the game or whatever's being rendered, basically. Now, the big trick there is you need support. Right, like the game engine has to support it. Like if you're not telling this thing to do these, making these calls to do some form of ray tracing for the scene, if you don't pass that information to the engine, it's not going to do anything with it. So you're not going to just magically get awesome reflections in older games. Like you need code changes to get this effect.
And they can be pretty impressive. There's like a Battlefield 5 demo that's making the round that actually shows the differences the RTX 280 will make. And when you see a demo that's set up to take advantage of the ray tracing with real-time light reflections with cinematic effects, this is really kind of crazy to look at. But the thing that I like how Jeremy put it. It will be interesting to see how the numbers match up once reviewers get their hands on these cards. Because when you look at the slides from the presentation, and that's a pretty badass. If you haven't seen this, you should search out this Battlefield 5 demo. But when you look at the chart they're sending out, it's like, Final Fantasy 15 HDR more than twice as fast, Epic Infiltrator more than twice as fast, PUBG practically twice as fast, Ark Survival Evolved more than twice as fast, Hitman 2 HDR 1.25 times as fast, Wolfenstein 2 1.5 times as fast, give or take, right? They're showing these numbers There's
also something else worth mentioning in that chart. So what you're referencing is just the dark green bars there, which are showing, about a 50% gain over the previous generation of the same card, basically, right? But then there's this extra feature, which is another thing that is game specific, has to be added somehow to the game engine so that it can turn this extra feature on, and that's called DLSS, which is, I mean, we've seen a few things in the past few weeks about NVIDIA doing machine learning based interesting like post-processing effects, right? Like there was one thing recently which I think was covered on the show 2 or 3 weeks ago, where they were taking video and they were emulating like what a faster frame rate of that video was, or they were doing other things like, getting more detail out of it, like the whole sci-fi version of enhance. Turns out you can actually do if you train a machine learning like array of systems and you give it the lower resolution and then you give it the higher resolution, and it's supposed to try to figure out how to get to the better resolution, like how to, what is most likely that missing data, right?
Right.
Well, it turns out you can take that sort of thing and you can sort of like, so that chart that we just showed here was for 4K gaming. Well, the idea is that you can get gaming frame rates closer to what you would normally need lower resolutions to achieve. But the trick is that the engine can run at a slightly lower resolution when it's rendering the game. And then this DLSS machine learning related sort of pipeline at the tail end of this post-processing at the tail end of the pipeline is able to bring that end result back up to a convincing 4K resolution image. And it's able to do that on the fly for every single frame as it's running, right? So the idea is that now for games that are supporting it correctly, and I imagine there's some dials and knobs and stuff that they have to turn in the driver to kind of tune this and then like make it work properly on a game specific basis. But end result, you get 4K 60 gaming out of, in this case, they're only talking about the 2080. They're not even talking about the 2080 Ti, which would potentially be even faster, right?
Right.
If it holds the same way that it held before, usually the Ti model is a roughly 50% gain over the non-Ti model of the same number. And that's probably going to be the case here, but they're only showing the 2080 results in that chart we just showed, right? Which actually I think was, I don't know if they just don't have the TI results ready, or maybe they were trying not to go crazy, like show off with their presentation and go, okay, like let's not show the $1,000 or $1,200 card as the thing that's able to do 4K 60. Like we can actually get there with one rung down, even though that one rung down is actually the price of what was previously like the 1080 Ti, right? Which was the high end card.
For me, it's you want to look forward when you're buying a GPU because it tends to be a very expensive purchase that you want to last for a long time on one hand. And on the other hand, so much of what people play are games that are, aging or aged at this point. And I gotta say, I'll be really curious to see what sort of the existing crop of sort of the classic, we're testing a GPU, let's roll out these games. I'm kind of really curious to see what the numbers and the performance are like, because with ray tracing, 6x the performance, it's super mondo awesome, cool. And on the other hand, it's like, okay, but what about all of the credible, back catalog of games that are not and probably will never have this implemented? I think it's going to be, I'm very curious to see what that is. I'm curious what availability is going to be like on these cards. We'll see.
Yeah, and those 6x or 8x or 10x claims that like they were kind of sprinkling throughout their presentation. That is if you tried to do these ray tracing effects on the previous generation hardware, right?
Right.
So yes, there are enormous gains over the prior generation if you want to get these same effects. In my mind, that's kind of a cheat though, because it's like, okay, this is something where the previous generation didn't even have hardware specifically designed for it, right? So, this newer stuff, the Turing architecture has these, ray tracing specific pipelines built into the silicon.
Right.
So yes, of course it's able to do it much faster, especially when you're doing hardware specific for a very specific type of math that's not something that you could usually optimize well on like some, like raster shaders and things like that.
To use a completely random comparison, it's like trying to have a bosun's maid twiddle the knobs on the reactor, or to have somebody that runs a nuclear reactor try to tie things to the deck of a boat. There's just, it's, you know what I mean?
Yeah,
it's just, there's also, there's a long history of, benchmarks in gaming and everywhere else where we choose a particularly optimal situation that you probably won't be able to run into in the real world, but it makes our thing look really big. I just said that.
But the effects are very impressive. I mean, we're looking at them on a screen at a press event, and then for all of us that weren't at the press event, seeing it only via TWiCH, which was completely killing the. It was juddering because the frame rate of TWiCH wasn't matching with the frame rate of the of the event and the live stream and whatnot. So we really have to be able to sit at a system and see these things in person to kind of like make that start to even attempt to make that judgment call on.
Right.
Are these differences really something that you're going to want to go after? And, or is it something where you would rather just get a higher frame rate with the newer hardware playing the game without these features even enabled? Because when you enable them, it's not like suddenly the game will go 4K 60. All right. If you're trying to do ray tracing, even hybrid ray tracing, those claims we were just looking at on that other slide where they were claiming 4K 60 gaming, that's probably not with RTX on. Now, it might be, but probably not. I'm thinking that frame rate's going to come down some to be able to do that sort of math. We're talking about something that was just, not a thing that was even feasible. And now suddenly we're doing it. I would be surprised if we're doing it at 4K 60 at the same time that this brand new, very complicated technology rolled out, right? Maybe we can get there with another generation or something. But, right now, I don't think it's going to be super fast frame rate and all this amazing, shadow effects and transparency effects and lighting effects and everything all at the same time. Maybe, once the game engine guys can do better optimizations and, sort of cut some extra corners and whatnot and squeeze a little bit more performance out of it, then maybe we'll get there. But not initially, I'm thinking. So between the prices, between that price mismatch between pre-orders and what's, I think, MSRPs, and the lack of a lot of titles that even can do this, when you put all that together, it's probably best to hold off on the pre-order and at least wait for the price to come down to what their stated price is, right? And then hopefully there'll be a couple more releases using the engine updates that can implement the ray tracing effects and whatnot.
Right.
And also there was no mention of VR throughout the whole event, which I was kind of trying to listen out for in case. But I think the reason that that's not a thing is because, again, trying to do ray tracing at the same time, you're not going to get 90 frames per second that you kind of need for VR. I don't think you can pull that off with ray tracing and everything else added. Maybe if it's like really primitive, maybe you can get some VR game that has a single, glass sphere and a couple of glass cubes and like some other stuff in a scene, and then maybe that can be ray traced and look really awesome and even be in VR.
I gotta, There's an article by a column article, whatever you want to call it, on Forbes by Jason Avanlo. My apologies if I just butchered your last name, but the title kind of sums it up: NVIDIA RTX 20 series, why you should jump off the hype train. And it's pointing out that ray tracing isn't everything. And it's something I thought I was in the same thing. And are they is this VR? Where is VR in this? But, here it is right here. Ask yourself why NVIDIA showed approximately 0 gaming benchmarks without ray tracing. There were no performance comparisons between, say, the GTX 1080 Ti and the RTX 2080 Ti for the most popular games already out there. Now
they did sort of rectify that with that other chart that we showed earlier.
Yeah.
Right? and I think they put that out right away because they got a lot of blowback, just like what's in this article. Like, hey, why didn't you show us what the regular gaming increases is, right? It's great that it does this. It's great that it does this, ray tracing thing and this extra stuff, and it does it way better than the previous generation. But this is a brand new technology that it's doing way better than the previous generation. We want to know how much faster is, the stuff we have right now going to go with this new, very expensive hardware. And that was in that other bar chart that we showed. At least those were NVIDIA's numbers, which NVIDIA hasn't really been that far off from reality on their published numbers in the past. So I don't really have any reason to doubt those figures.
True, but
that should be roughly what we see when we do the testing.
But it's like, man, we don't know the real world performance. These are the Founders Edition prices, and we can expect what I feel in the group. We're going to say I feel. I feel that there's going to be a significant price reduction once we move past the early adopter. Because right now, there are people ordering these cards right now, pre-ordering these cards right now, because they want the newest, best, as fast as ever. But they're paying extra to be early adopters. And it was interesting. One of the things that came out in that article on Forbes was he says, quote, there's a strong chance NVIDIA will release 7 nanometer versions in 2019. RTX uses the 12 nanometer process. And that means performance gains, power efficiency gains, and, more memory capacity.
Yeah, that's another important part of this. The Turing die is enormous, right? They're taking, they're adding more shaders, they're adding, more cores, they're adding on this extra, like 2 extra sets of sections of silicon, one for all the ray tracing stuff, another one for the machine learning based post-processing stuff, right? So there's more transistors on this thing, right? It's just going to be bigger. They didn't do it in conjunction with the shrink. So the end result is more power draw, which actually translates to first of all, the reference cooler is now a dual fan cooler, not a single, right? Also for the TI models, like 2080 Ti, you're looking at not a 2-slot design, but for what I've seen so far, 2.5 to 3-slot designs. So yes, more power draw. I think these cards have dual 8-pin power connectors on them, where previously we're used to an 8 and a 6 for a TI, and sometimes just a couple of 6s or a single 8 for a 1080, right?
Right.
So yeah, more power draw this time. So that yes, they're clearly that while they did have these great power consumption, power efficiency gains on the last generation that we saw with Pascal, I'm sure all those same power efficiency applies. It's just that you've now increased the transistor count by so much, and there's just so much other stuff going on that it just it's simply more things in parallel. So it's just going to take more power. So yes, the next generation with a shrink, they would probably make some more slight improvements. Maybe they can squeeze more of those ray tracing cores in there. Squeeze more of the other things that they're trying to, make the experience better with and whatnot. Do that in conjunction with a shrink, and try to do another power efficiency pass again. It's almost like these are kind of like doing what Intel's TikTok used to do. Right. I say used to because now they're in a waltz or a whatever the heck their thing is, where they're doing 2 talks or something. It used to be, it used to be a new architecture kind of thing, like change the structure of things. And then the next pass was like an optimize, where they would try to get power back. So NVIDIA is now kind of falling into this, right? They just added a whole bunch of stuff, but power consumption went up. The next generation will probably be an optimized pass, and they'll try to get the, power consumption back down again, and shrink the die some, hopefully. Because that's just enormous, and that's part of the reason for the cost, right? If you can only get so many of these GPUs off of a single wafer, because they're just so dang big, then it's just going to translate to more raw cost of
I feel comfortable in saying there are many compelling reasons to not pre-order this guy. I mean, look, if you've got the money and you don't care that it's going to be available for less money, possibly with a better, because this is for Founders Edition cards have traditionally had really mediocre cooling solutions. These seem to be better than mediocre. Damning with faint praise, I know. But if you don't worry, if you are not worried that there will be the same card for less money, possibly with better performance because it has a better integrated cooling solution, by all means buy these cards. If you aren't, particularly worried about potentially AMD releasing something that works a lot better with your games, or whether or not there's going to be some sort of long, at this point I feel like, oh great, NVIDIA's got ray tracing. If AMD doesn't do ray tracing, then we've got something that makes, FreeSync versus G-Sync look, relatively manageable by comparison. So
there's one thing we haven't mentioned before we move on about these is they now have an integrated connector designed for VR headsets. So this is a DisplayPort / Thunderbolt style connector. Apparently it can provide up to 30 watts of power. This is directly from the GPU. So the theory would be that you have your VR headset with, I don't know if they're going to retrofit the older ones to give you a different breakout box or whatnot, but you would in theory just have a single connection to the computer, and that would be via the GPU. And it would provide power. It would provide USB via, over Thunderbolt. It would provide it would use the DisplayPort link as its means to get the video data out to you. Should make things more seamless. I don't know if it really does anything for latency and whatnot, but just that all being built in is kind of a convenience. I do know that VR headsets in the past, like especially the Vive, is super picky about its USB connection. Right. And sometimes it wants like a USB 3 connection, and some chipsets just don't have solid compatibility there. We're not really sure who's to blame, but it's kind of a finicky thing. Actually, several people that I know have had, they have a system that none of the USB 3 ports will work properly with a Vive, as an example.
Ouch.
Yeah, so something like this, just being built in, then that kind of solves a lot of the headaches and potentially just makes things just way easier to do moving forward, right? And just one plug the thing in. Yep, there it is. VR works. Oh wait, that's the name of the variable rate shading thing. What's the name of the port? Virtual Link. Yeah, Virtual Link standard.
It's got a nice ring to it.
Yeah, I mean, it makes sense. It seems like the next logical thing to do. Now, you're designing an entire port around something that some people would still argue is a very niche sort of thing that only some people have, and even the people that have it aren't using it all the time.
It may be niche to you, but it's a potential huge market for GPU manufacturers that are desperately seeking people to need more than 1080p processing.
Yeah, don't get me wrong. Like at home, I have a 1080 Ti and I have a Rift and a Vive. And I've used them recently, even. But it's just they're still caught in the chicken and the egg thing, right? There needs to be more good games, more good software for it. And then that's the thing where not all the developers are jumping on that hype train because there's just not a lot of an install base of which to distribute those titles when they make them, right? So we're still caught in that. I think it has promise. There's a few VR games I've played that have been just phenomenal. But there's just not enough of them yet for it to be like a critical mass sort of thing. Unfortunately.
It would be nice for it to reach critical mass. I just want to say that. It would be nice.
It would be nice.
We are contemplating a build over at Tech Thing that I affectionately think of as Project Unicorn Vomit, which is to see how many RGB LED devices we can cram inside of a single PC case. And of course, the PC case itself will hopefully have RGB fans and other lighting devices inside of it.
Oh, well, then you absolutely need these ATX power cables.
Leanne Lee taking it to the next level.
Yeah.
A 24-pin ATX power cable, writes Jeremy Hellstrom, 200 millimeters in length or roughly 7.8 inches long. 2 parts to the cable. The white one transfers the power while the clear RGB cable attaches to the top of the white with clips. It also ships with a controller, which you can use if your motherboard lacks a 3-pin RGB header. That's rare to find these days, he adds. If you need a rainbow bridge in your system to take your RGB addiction to new levels, this might be worth picking up. Yes. ATX power cables and RGB lighting, taking it to the next level. And there's a nice write-up, link to a write-up on that Lian Li 24-pin RGB extension cable up on guru3d.com. Can't stop laughing about that. Because, as if RGB motherboards and RGB case lighting, RGB keyboards all throbbing together is not satisfying. Oh, and the RGB cooler on your AMD processor aren't enough for you. Lian Li's figured out yet another spot for you to get the unicorn vomit rolling. It's not inexpensive.
No, it's not. We were looking around last night.
Euros?
I think it's like, yeah, I think there was going for a little bit cheaper than that. Was something like the equivalent of $50 US. I think it was, we found it on Newegg or something like that. So the pricing seems disproportionately high in euros compared to dollars right now.
Well,
but
currency valuations are complicated things.
if you're into RGBs and you want the unicorn vomit style case, as Patrick puts it, then that's definitely a thing that you would consider.
Yeah, and it's cool neon lighting effects. It looks like, or I don't know. I'm kind of curious to learn more about what they're to get kind of closer into it. It ends up it's not going to be as pliable as a regular power cable, but it's certainly going to be prettier.
Yeah.
It just makes me laugh, and it's there if you need it. And it launches with a rainbow animation. You do need space behind the motherboard tray to fit it. The Lian Li Strimer. Show yourself. I just had to cover that because it's pretty out of control. There's, there you go. Oh, yeah. There's some more bright effects. By the way, it also comes with a PCI bracket. So you can control the lighting that way. Magnificent. Yeah. Enable the components inside of the chassis. Glorious. I'm particularly enjoying Lian Li's webpage on this. I don't hear glorious in 24-pin RG or 24-pin power cables used in the same sentence. And so those are actually fiber optic lines. And they have LEDs in the end of it that illuminate the length of the device. Fascinating. Another fascinating news. We should probably ask. I mean, you're the hardware guy. You're the storage guy.
I'm one of them.
Technically, we're both hardware guys. You're kind of the storage. In this guru, you are by far and beyond the storage guru. Any thoughts on where the value is? Because I was blown away and looking at how inexpensive 1 terabyte drives had gotten. Now, you pointed out that I was looking at SATA drives, not sort of M.2 or NVMe drives. But you're looking at some very respectable drives, some very respectable 2.5-inch SATA SSD drives, 1 terabyte model starting at under $300 now.
You do have Intel with that new 660p. That came out, which their play was trying to get NVMe parts to come down to SATA pricing, which I think they've accomplished, although the 1 terabyte model I don't think has hit the street yet. But I mean, that's pretty impressive from them. 512 gig drive for $200, I think. The 1 terabyte's supposed to be $400. Or wait, no, it's half that. Sorry. Right. They're basically the 660p is like 20 cents a gig across the board.
Yeah. I mean, it's crazy because you're looking at
which is
A
good.
Samsung,
right?
A Samsung 850 Evo for $240, 1 terabyte. Crucial MX 300, 1 terabyte for $225. You can get $174 if you want to try Mushkin's Reactor. These are, but the Crucial, the MX 300 and the Samsung 850 Evo, those are decent drives, and that's just you're looking like it's like 24 cents. So the 660p though is going to give you a healthy performance boost over that. Is a normal person that's like opening video games or saving 2 gigabyte video files, are they going to notice the delta between an SSD drive and an NVMe drive in everyday use?
Well, remember that the 660p, while it's NVMe, which will give you some potentially noticeable differences over SATA, because when you're launching something that's doing, if you're launching games or you're launching things that have kind of like bulky, like large data files to them, then you're leaning more on the sequential transfer speed of the SSD. And in the case of NVMe, even for the 660p, which is more meant to be a budget part, you still have that faster interface. It's still going to do 2 to 3 to 4 times the throughput, the raw sequential throughput that you can get compared to a SATA SSD. It doesn't matter how good the SATA SSD is.
Right.
It's still bottlenecked by the interface, right? Then most of them have been that way for years, where you're basically riding the interface bandwidth limit almost immediately. So yeah, you're gonna see some things be snappier and quicker. Now there is a potential downside to that, and that is if you are like a serious power user type and if you're the kind of person that you beat on the storage a lot, like you're doing workloads that are just really kind of like, you have VMs sitting on the storage and you're running multiple of them at the same time and they're all doing random IO at the same time, or, that sort of thing. Something that's like a drive like the 660p might not be for you, especially if you're after one of the smaller capacities of it. And I say that because 660p has quad level cell flash, or 4 bits per cell, which means that the write speed is significantly slower than TLC or MLC, like any of the lower number, fewer bits per cell format flash. But the 660p does a lot of tricks to mask that problem. It has as much of its media as possible is actually running in SLC mode instead of QLC mode. It's able to kind of switch that on the fly. So if you're the kind of person that needs a lot of storage, if you're going to get like the 1 terabyte model once it hits the street, that would be an ideal Steam game drive to me. If that's where you were going with that, with your statement, because once you get into the higher capacities, it almost doesn't matter if it's 4-bit per cell flash, because there will be at least, I think on the 1 terabyte model, there'll be something like at least a dozen or 2 gigabytes of SLC that's always there as a cache. And then if the drive is not completely full, there will be potentially even more than that. If you start with the 1 terabyte 660p and you start it in an empty state, you have over 200 gigabytes worth of SLC available. So you could literally just dump 200 gig on that thing in one short burst. And also you'd have to have a source that could read 200 gig at like several gigabytes per second. So yeah, I mean, once you get into those larger capacities, it's almost a no-brainer, especially when you talk 1 terabyte for a couple $100 and it's an NVMe SSD.
No, that makes sense. I mean, because looking at like a 970 Evo, 500 gigabytes, $180, 970 Pro, 512 gigabytes, $230. For most mainstream NVMe SSDs, you're getting half the capacity.
Exactly. Right. So where that person was eyeballing the 0.5 terabyte models for that potential like Steam game drive usage, now you just get to double it for the same price. Right.
Not so good if you're a video editor.
Well, honestly, so we did some testing. Actually, we did some testing on the Shroud Research side for what do if you were editing video, or say you were rendering out a video, right? What would that look like as far as impacting SSDs, particularly if you had something like a QLC SSD. What if that was the destination drive of the video you were rendering, right? Turns out when you're rendering video, the output, like, it's slow. like a hard drive has no problem storing, like, handling that incoming stream. I mean, you're talking, in some case, you're talking like a few megabytes per second. So,
right.
Even at the quad level cell, assuming that you somehow rendered a video for such a long time that you were able to outpace how fast the cache could empty, which actually is not even a thing.
Right.
It would be no problem. And as far as scrubbing video, in other words, that's the other pain point for video editors, is you want the source video to be located on some storage device that's relatively fast.
Right.
That would be no problem on a drive like this either. The only potential issue would be that the endurance on QLC drives is lower than what it is on TLC and MLC. Not by a lot, but it is noticeable. I mean, theoretically it's half, but they've tried to make it a little bit better than half of the endurance. But it's still a very high number, right? At TLC SSDs had enough endurance that you'd have to really kind of thrash them in day-to-day use in order to run the drive's endurance out before you ran out of the drive's 3 or 5 year warranty period. 660p, if you take like the worst case, like the smallest 660p, it works out to something. It was something on the order of like 50 gig per day.
Mm-hmm.
So if you're passing
which is a lot
bunch
more
of video, yes, but if you're doing like day-to-day video editing and you're constantly dumping, dozens of gigabytes of video, possibly hundreds of gigabytes of video, if you're doing like 4K, high bitrate video and whatnot, you could potentially burn through that endurance on a drive like this before you hit the 5-year rating.
Right.
But honestly, you spent half as much on the drive, so there has to be a disadvantage somewhere, right? You got twice the capacity for the same cost, or you spent half as much. So it just kind of is what it is, right? That's one of those situations where you have to pay attention to what's your actual use case. Now, for for you and me, even, and just average Joe, just using their laptop, and they just want to put a cheap upgrade drive in the thing, something like QLC. Don't be afraid of QLC, because another part of that testing I was doing was I did a full Windows reinstall on a machine. Installed Office, installed all the drivers, including like the NVIDIA GPU driver, which is enormous. I did like all those things you would do. Like, what's your worst case in a day kind of load? Yeah. Not just dumping media on it, but actually doing something, like installing things, right? What would that worst case look like? And it was something like 25 gig. Full Windows install, full Office, drivers, everything, like pretty much the round of stuff you would stick on the system to get it up and running at least, right? So
you can only do that for several years running every single day before wearing out the drive.
Well, you can only do that every day, including weekends, for 10 years to run out the endurance on the 5-year rated drive. Yes.
10 is several.
Yeah. So, I mean, you're probably good. Now, on the flip side to that, if the drive's rated 50 gig per day and you go to download something like Doom on Steam, we actually found, I don't know if it counts as a bug or an issue. Steam, for most games, will pre-allocate the space for the download before it actually starts doing the download. And it only does it for some files of the game of a given game. So some games will do this not as much as others. Doom does it with almost all of the content, which means the Doom download, it's a 70 gig download. But if you actually look at how much data gets written to the SSD during that download, it's closer to 140, because it does this allocation pass, which does a full write of all of, even though it's not writing anything, it's just basically writing zeros, just empty space. And then it downloads all the content, which is another full, writing of 70 gig worth of data. So yeah, if you download Doom, you're going to burn through almost, like several days worth of the endurance of a drive like this. But are you downloading Doom every day? Are you downloading 70 gigabyte games every day? Probably not. So average that out over the life of the drive, there's going to be plenty of days where you're not downloading anything, and then you'll kind of make that back up. But I still think Steam kind of needs to fix that problem, because it's going to start being an issue when you write 2x the amount that you needed to write to download something from the internet.
It's a new trend. It's a lifestyle choice.
No. Actually, I think Steam's been doing this.
Samsung
for
paid
forever.
them.
Well, it's actually bad for Samsung drives too. You're burning through whatever the endurance is at 2x the rate that you should be. That's Steam's probably the worst offender I've found in that. Everything else is pretty much it's usually just a 1-to-1 ratio. You go to download a bunch of media off of your memory card from your SD card from your camera. 50 gig worth of pictures. That's just straight 50 gig worth of writes. No muss, no fuss there.
It seems obvious.
It seems obvious. Yeah.
Oh my goodness, we should give it. Sorry. I want to point out really quickly, if you're used to normally just I'll buy it on Amazon, it'll be cheapest there. With computer parts, especially GPUs and SSDs, just eyeball. Less so with SSDs, more so with GPUs. Just eyeball the prices on Newegg and some other places too, because like that, there's only the only Intel 660p drive I can find for sale anywhere is that 512 gigabyte version, which is selling for $100 with free shipping. I guess technically it might be a sale, but it's $100 on Newegg with free 3-day shipping. Versus like $115 on $115 from a third party selling through Amazon. So especially with computer parts, eyeball around and compare prices, because you may save yourself a fairly significant chunk of change over the course of buying a whole bunch of stuff inside a new PC. One last thought before we go. Logitech G Pro wireless and G Pro gaming mice review. Christopher Koch did this for PC Per. So if you're not familiar with the esports universe, there are professional gamers. Some of them make a lot of money. All of them will spank you quite handily at almost any video game you choose to play, much less the ones they are making their money at. And they introduced their new Hero 16K sensor. Yeah, these are mice.
Yeah, they're mice. What I still need to reconfirm with them is if this sensor is fast enough that they didn't even bother with the accelerometer thing anymore. I'm not sure.
Right.
It could very well still be in there, especially if it's an esports and a gaming specific thing. I'd figure maybe the accelerometer is just in there as a backup. But these are just, nicer, more refined, kind of top of the line versions of what you've seen before. And what's missing is there's no more numbers, right? Mm-hmm. Usually there's like G560 or G, whatever number, some 3-digit number after a G usually. But you get the wired and the wireless version. The wireless version has a blank puck on the bottom where you can use the wireless version with the wireless charging mat that Logitech put out, several months ago. And it's basically a little insert that you kind of unscrew and it pops out, and then the charging mat comes with a different puck that is like the inductive receiver. There it is right there in that picture. But that doesn't mean that's the only way to charge the wireless one. It actually does something that's the same as the prior, more recent Logitech wireless mice, and that is the wireless version actually comes with a cord. It's just a cord with a unique looking end on it. And it's basically a micro USB connector that just has a couple of extra spades off to the side of it to kind of like make it more stable. And all that cord does is it plugs directly into the kind of nose of the mouse. And it kind of transforms the wireless model into a wired model. Like it really just looks just like a normal wired mouse. But then when you want to go wireless, there's this fob style, like a little kind of adapter that the wireless dongle that you would usually plug into your laptop plugs into one end of this kind of adapter, and then the other end of the adapter plugs into the end of that cable instead of the mouse. So when you want to go wireless, you basically just disconnect the wired connection, plug it into the wireless receiver, and then it's a seamless, usually people will just leave that thing kind of sitting on their desk, like near their mouse pad. And it comes in really handy. Like since those mice are super low latency in the wireless mode, I'm usually super sensitive to that sort of thing. I'm the kind of guy that, like, back when the Dell switched from the Synaptics touchpad to like started with an A, Alps or whatever touchpad, and it like added a few milliseconds of latency, like that drove me nuts. So like I'm really sensitive to like input latency on devices. You can't tell at all if you're wired or wireless on mice like these. So that's an advantage because you're using it wirelessly most of the time, but then the Logitech software gives you a little pop-up on your desktop when your battery gets low, like 10% or whatnot, and it's seamless. You just unplug this dongle thing from the end of the cable, you plug the cable in the end of the mouse, you just keep going. It's as if you didn't even change anything, except now there's a wire there for, and you just use it as you would for like the next 30 minutes or so, and usually it's charged up fully, and then you just switch it back and you're back to wireless.
This is a good thing.
They made that bottom piece, that the cap that unscrews, you can see the contacts in the base for where the wireless charging puck would contact the mouse. But they've also added a compartment, finally, for the dongle, so that you can have that with the mouse and you just throw it in your bag when you're traveling, which makes a lot more sense than the way it's been previously, which is, you always had to, I usually had to take the dongle and stick it on my laptop before I put my laptop in my bag, and then I'm always worried that thing's going to be like at the bottom or just hitting up against stuff and potentially messing up the USB port. So yes, I very much like that you could separate that, keep it with the mouse when you're traveling, and not have to deal with that.
So the Hero 16K sensor, max resolution 16,000 dpi, minimum resolution 100 dpi, maximum acceleration tested at 40 Gs. 400 inches per second. It's just an unhinged collection of specs on this. I was kind of amazed. The wired G Pro with its 6.5-foot cable, $70 at LogitechG.com, and the G Pro wireless is $149.99. So they look very nice. They really do. I was really fascinated with how much the wireless Pro version looks like a Microsoft mouse from above. I'm just going to say that, which for me is a good thing. The farther,
just simple design, right? Like they've slowly been like evolving back to that shape. Like, well, you can look like 3 or 4 generations back, and they've slowly been morphing.
There was just this point where the mice were starting to look like Klingon battle tools, or the controls for a Klingon battle station, rather than something you would actually want to hold in your hand for several hours while gaming. So props to Logitech.
Like, not only that's significant that they're gaming mice and also look like normal mice, right? Again, without the Klingon shape to a mouse is one thing, but typically anytime it was gaming, it was always that shape. Right? Some crazy thing, which totally turned me off to them, regardless of how good the specs were. I was just like, no, it needs to be comfortable while I'm using the thing.
We wait with bated breath. For what? I don't know. Probably for the next thing to happen. For example,
for the RTX cards.
Yeah. Well, I don't anticipate NVIDIA letting anybody write about the RTX parts until the cards are already available on the street to buy. It's call me crazy. I would not be shocked by that, but I'm really curious to see what the real world performance on those cards is going to be. And I am delighted to watch, those sub 215 millimeter 1070 and 1080 GPUs get that much closer to affordability for a build for me. So this is all very exciting. With that, ladies and gentlemen, we want to thank you for listening to This Week in Computer Hardware. Twitch is available, from twit.tv/Twitch. That gives you all the links for all the places you can download it, or just search for This Week in Computer Hardware or Twitch in your favorite podcasting device. Joining me today has been the lovely dulcet tones of Mr. Alan Malventano of PCPer.com. And Alan, if memory serves, you're at Malventano on the Twitters.
I am.
Any projects you want to promote or anything exciting going on in the PC?
So there's an SSD I was writing up before the show. That's, go figure, RGB built into an SSD.
Shocking.
I don't know how I feel about that. I mean, it looks cool if the RGB thing is your thing. It's even multi-channel RGB. It's like 8 color channels in there, and
really?
In an
SSD,
I suppose it will look great. It would look great. Yeah, like the face of the SSD is like semi-transparent, and it has like 8 bands of, and you can actually have like rippling rainbows or whatever, just kind of like rolling across the face of the SSD.
Is it from a major manufacturer or someone?
No.
Okay.
I forget the name, but it's it's one of those smaller name companies, and the SSD itself is like the super tiny PCB. In there out of the whole thing, which is kind of par for the course these days. Anyway, got a review of that. We had this, I think it was the Falcon Northwest case, that nice blue case that we had come in a few weeks back that Ken did the review of. That happened to have a 1.5 terabyte 905p Optane drive in it.
Really?
Which doesn't exist as far as anybody else understands. But we asked them, and they're like, yeah, you can review the drive if you want. So I might have liberated that SSD from that Falcon Northwest system for a few days, and
sweet.
Yep, there it is. 1.5 terabyte U.2, which is also interesting because usually you wouldn't be able to fit 1.5 terabytes worth of Optane memory dies. Like their packages, you can only normally stack them so high in a package, and you can only fit so many packages on a PCB that's inside the U.2 form factor, since that's basically like a 2.5-inch SSD form factor. It's a little thicker, but still, kind of tricky to get cram all that stuff in there. So, yep, and there's the drive. Fun fact, that connector is hot glued to the SSD. Falcon Northwest really did not want anything getting loose during shipment. I remember blame them.
Manufacturers doing that, hot gluing cards in place.
Yeah, I mean, I would rather it be hot glued than fall out. That's fine, but it did not make my life easy when I was trying to get in there. But I prevailed, thanks to the iFixit toolkit.
There you have it, ladies and gentlemen. iFixit, by the way, is a sponsor occasionally, but not currently for This Week in Computer Hardware. So that was an unprompted reference. Or unpaid reference.
Yeah, so there's some upcoming storage stuff, just not all wrapped up yet.
There you have it.
You know me, I'm picky on this testing thing. I got to make sure the tests are done correctly.
Sometimes that leads to done correctly.
Sometimes that leads to less quantity for the higher quality, unfortunately.
We'll go for quality, Alan. You're a quality kind of guy.
I try.
With that, ladies and gentlemen, you succeed. I'm Patrick Norton. You can find me at tekthiing.com, techthing.com, which is the weekly podcast I do with Shannon Morris. We talked about it last week. I spent a bunch of time with the Motorola E4, and Shannon's got a rather awesome collection of DEF CON badges in this week's show, along with a whole bunch of Chrome extensions. And you can also find me at avxl.com. It's the home theater and audio podcast I host with Mr. Robert Heron. And we just recorded a fresh version of that today, a new episode, which will be very exciting, and discussing the possibility of 8K Samsung monitors becoming a real live, you can buy them right now kind of thing, which may be happening at CEDIA this year. But I won't know until I get to CEDIA, and that's actually not until September. So with that, ladies and gentlemen, thank you so much for listening to this episode of This Week in Computer Hardware. Mr. Malventano, thank you so much for joining us here in Mr. Shrout's place while he finishes his 93-day tour of half of the universe, which I guess technically is a 16-day tour. You took the 93-day tour, but I think Ryan is just as tired after 2 weeks as you were after several weeks.
Yes.
He's been flying.
Actually, as soon as we're done, I'm getting in the car and picking that man up from the airport.
Oh my goodness! Give him a hug for me. Buy him a glass of milk and a cookie. Tell him it's going to be okay. With that, ladies and gentlemen, I'm Patrick Norton.
I'm Alan Malventano.
Catch you next week on Twitch.